So now something a little different. Oops, I've lost my. We're gonna have one other final sit-down interview, but first, let me introduce you to Kyle Morgenstein. Kyle.
Hi, good to meet all of you.
And you are from. So what? You're a computer science department or robotics or some combination?
Technically, I'm in the aerospace department, but it's part of Texas Robotics. And so I'm a final year PhD student here where I work with robots like this guy here. See if I can stand him up in just a moment.
But before, let me ask you something, because you have a weird background. You said like, geology and other things. So how do you even end up here?
Yeah, so originally I was a geologist, and I was at NASA doing some of the work on the Mars rover, looking for signs of life on Mars. And we have the rover drive around looking for interesting rocks that might show us that there used to be life or other minerals. But a lot of the samples we really care about aren't just laying on the ground, easy for us to find. They're maybe on cliff faces or down lava tubes or in caves. It's very hard for the rover to get into those spaces. So I started working on other types of robots, robot snakes, robot dogs, humanoid robots. So that really brought me into robotics and then here to UT to do my PhD. But it all started with looking for rocks that hopefully might find aliens one day.
And so this is the Go One.
Yes, yeah.
From Unitree.
Yeah, Unitree.
And you said what? Unitree is a Chinese company?
Yeah, it's a Chinese company that makes these smaller robot dogs and now robot humanoids. If you saw Rizbot last year terrorizing Austin with good charisma, I guess, had a cowboy hat, some sunglasses. So it's a company that makes these lower cost robots for researchers and developers primarily to learn how to interact with these sorts of systems.
And in comparison to the Rizbot, how charismatic is Go One?
Well, you'll have to answer that for yourselves.
All right.
Let's see what I can do with it. Let's stand it up real quick.
So how do you, when you refer to this robot, do you use a gender or an it, or how do you usually refer to it?
Yeah, I think for...
No offense.
I think for many years I said it, but usually people name their robots. So at a company that I work with, we name our robot Apollo. Maybe you've seen Spot, the robot dog from Boston Dynamics that we worked with. But a lot of times people like to come up with their own names, so the Ninja Turtles are very popular names, and then they sort of take on that personality and the genders that come with it.
So have you named this one?
So my girlfriend's mother calls it Goey, and so Goey is a boy, I think.
Okay.
It's a nice little dog. How about, Goey, do you want to say hi to everybody? There we go. Now
don't... Is this, like, it's modeled somewhat on a dog, or?
Or
any quadruped?
Yeah, so you might see there's some other companies that make robot dogs where the back legs are flipped, so it's a symmetric forwards and backwards. You can see that knee joint always points forwards like a dog's would. So it's different companies have different takes on it. Even for humanoids, most of them have similar knee joints to ours, but there's a company in Oregon called Agility, and they actually have bird leg models for their robots. So it's a human size, but it's the knees bend backwards, and they find it has better stability for bending low to pick up heavy boxes, things like that.
Are those bent backwards knees?
Yeah, I guess the back legs would. I don't know. I think I had hermit crabs growing up, so I haven't spent as much time looking at dog legs maybe as I'd like to.
Okay, so Goey, what can Goey do?
Well, he's got a little dance that he wants to show all of you, but you have to cheer really loud. He's very shy. Yeah, I see one going. There we go. Thank you. Okay, maybe you'll do it. Let's see.
Do we need the band?
We shouldn't. Oop. Oh, I turned him off. 1 second.
Are people in the front row safe?
They are very safe. It's an operator error, I promise.
Oh, really?
I can put it on the table. He will not dance on the table.
No.
Let's see if I can stand him up. Up he comes. There we go. All right, are you ready to dance? There we go. Little butt.
I didn't know it was going to be that kind of show. I'm sorry. Whoa.
There we go. Now he's got one more trick. I will warn you, it did knock over the band member's beer and guitar before the show, so we'll give him a little bit of extra space. Let's see. If all goes well, I will not lose my job. All right.
Could I disarm this robot by pouring my cup of water on it?
Yeah, you definitely could.
That's actually...
And we stick the landing. There we go.
Very nice. So this robot is not autonomous. You're
No, I am controlling it. You are all safe, I promise.
Well, that's if we trust you.
Well, if you trust me.
But all these kinds of movements, I imagine, like we've seen with, you mentioned Boston Dynamics and some of the, we're seeing movements that were not possible just fairly recently, right?
Yeah, absolutely. So
dexterity, I guess?
Totally. And so I think one of the big themes of the last couple of years has been taking data from people through motion capture suits or YouTube videos or recording people doing behaviors and trying to teach the robots how to mimic the way we move through the world. I think most of robotics for the last 50 years or so has been very programmatic. It's been, an engineer sits in a room and designs a behavior. Even all of these dances were very much designed by hand. And then the robot executes that sequence of actions. But now that we have a lot more data of how people go through the world, how you experience space, one of the research topics I care about is what does it mean to make people feel comfortable? How close should the robot stand to me? How close should it follow me? How does it change lanes when walking through a hallway? And having this kind of data allows it to behave much more fluidly than it ever could have in the past.
Oh yeah, what's the point? Like at this point, what's the point of this robot? What can it do? Is this just to demonstrate something? Or?
Yeah, this specific robot is mostly for demonstrations. I sort of joke it's a rich kid Christmas gift at this point. The cheap ones are about $1,500, and they sell it with a little, if you remember the Nintendo DS Pokemon game, the little step counter, they sell it with that. You can go for a run and the robot will follow you around like a real dog. But it doesn't have a huge commercial purpose. I think the main selling point for quadrupeds, if you had a sensor that was very expensive, too heavy to fly on a drone, it's expensive so you couldn't just buy multiple, and you had a terrain that had stairs or other clutter, then you might put it on the back of a quadruped and just move the sensor through your facility. So for oil and gas rigs, for example, they use quadrupeds with very expensive infrared sensors. The sensor is too heavy for a drone to fly, there's lots of stairs and vibrations, and so they can't use a wheeled platform, and so these platforms end up being really, really helpful for that kind of application. But they don't have the arms to be able to do all of the tasks we might care about, which is then part of why you're seeing this big push for humanoids now, because they have the ability to do useful tasks for you.
And do we expect to see this incorporating being autonomous by incorporating something like ChatGPT or some other AI?
Absolutely. And something that companies are working pretty hard on right now is how do you give it sort of this two-system approach? You've got a large, slow reasoning part of your brain. That's what ChatGPT would be. And then a much faster reactive motion control policy, which gives it the physical intelligence to interact with the world around it, to stay upright on its feet, to not fall over. And so the question then is, what parts of your brain do you use for different tasks? When I'm just folding socks, I might think that that's a pretty easy task for myself. I do it mindlessly while watching television. But for a robot, that's actually very hard. It's something called Moravec's paradox, where something that a human finds very easy is very hard for a computer. But things that are very easy for a computer, like multiplying 18-digit numbers, I would struggle a little bit with. Yeah. Only a little, but I would struggle.
Hard enough to fold socks, but try to get it to put on socks even.
Yeah, now that's robot feet design is a brand new, wide open field. So if you're very passionate, is a
so
job
what
for you.
else? I don't know. We have to wrap up, but any other little tidbit that you were hoping to share with us, or something we can look forward to? Find more information?
Yeah, totally. So I'm, like I said, finishing up my PhD, but I'm also an engineer at Aptronics. It's a humanoid company here in Austin. And I think something to look forward to is we're seeing a lot more work going into these humanoid companies. And I think there's an opportunity that technology has largely been a force for alienation in the last 20 years. Maybe that's pessimistic, but taking your time to look at social media and scroll and spend less time with your friends. But I think that robotics is a really cool opportunity to flip the script. The question is not what do you need from the technology, it's what can I take my time back for. So if it's a humanoid robot, if I don't have to do things like doing the laundry or doing the dishes, I get more time to spend time with my friends or take care of my kids. I think there's a huge opportunity there, and I'm really excited about that future, and I'm excited to hopefully build with a lot of you.
Do you think that Elon Musk has been making predictions about selling his humanoid robots by the millions, and that everyone will have one? I don't know if he's expecting to just give them to us, or we're supposed to be able to afford them, but do you think that that's realistic at all?
He said that cars would drive themselves by 2016. It's 2026, and we are almost there. So give him some time.
Okay.
Yeah.
Thank you very much, Kyle Morgenstein.
Yeah. Thank you.
And go one, go-y. Thank you.